Hey guys, I wanted to share with you another project I'm working on, which is a BarTop or desktop arcade machine. It's still not finished 100%, but it's functional and I wanted to show it the way I have it right now. I'll actually start off by explaining the stock parts here and then move on to this custom controller thing I actually built. Okay, so at the heart of the whole thing is a very old Pentium 2 computer. And when I say computer, I mean all the components of one minus the actual box. You can see here there's the actual Pentium 2 processor and then graphics card, network card and sound card. The hard disk is an 8 gig hard disk, I believe, and this wire that you see over here is my ghetto power on switch. So I turned the thing by actually shorting these two wires. The small thing here is a USB powered speaker. This is here just temporary until I actually build the housing for the whole thing and I can get bigger speakers and put them in. You can see here there's the power supply, which I have no idea how powerful that actually is. It came with this computer a while ago, so yeah. This green thing that you see underneath is actually a converter that converts the old MIDI type connectors for joysticks into a USB connector, and it's plugged in right over here. The other joystick is plugged in the sound card right here. I'll actually get to them in a while and explain more about the actual joysticks I used. Let me just move on through the whole thing. Okay, the monitor is an old CRT monitor which will probably get replaced with a bigger one once I actually decide to put this in a permanent housing. You can see here is the keyboard and the mouse. I'm not actually using the mouse too much. Most of the things are done with the keyboard, so I'm not even sure if I'm gonna put it when I actually close this thing up. Okay, so here's my custom controller, which is basically what I wanted to show you because everything else is more or less stock. You can see here I actually made holes in a piece of wood and put some arcade type buttons here. I have no idea where I got these from, it was a while back, but you can probably find some packages similar to what I had, and the joysticks as well. On the side you can actually see I put buttons on this and on the other side as well, and I actually put them there if you're gonna play some pinball type games. I think this is more easier and fun to play around with. Okay, so the interesting thing about this whole build is that I actually had some real old analog joysticks laying around, and I built this thing from analog joysticks. Moreover, I built them from joysticks that connect to the old MIDI ports, as I showed you right here. If you're gonna replicate this project and do it right now, I would actually beg you not to use these types of joysticks because they are pain, and I'll explain why. Just go ahead and buy some cheap digital joysticks that plug in on a USB port, and this whole project will take you much less time than it took me. Right now on this computer, I actually, in the USB port, I have only this converter plugged in, and again the joysticks is in MIDI connector and another MIDI connector right about here. Okay, it's just that I had these lying around gathering dust, so I figured, okay, I'll just reuse them. Okay, the problem with using the analog joysticks is the following one. I have a digital one here. Unfortunately, I found this after I already built the thing, so I didn't use this one. It would actually save me a lot of time and effort. But the problem with these types of joysticks is the following. On a digital joystick, whenever you push a button, you actually short two wires underneath, or leads, whatever you want to call them. And even if you actually push the buttons on the D-pad, they more or less do the same function. So if you push left, you short the left button underneath and you force your character or whatever to move left. However, on an analog joystick, the situation is a little bit more complex, because what an analog joystick basically is a variable resistor. So the top left position has one resistance, probably 0 or no resistance at all. Then the middle one has some middle resistance, and the right one has the maximum resistance of the variable resistor. What this means is that, and actually in Windows, I believe they were debugging it something like 0 to 255. So it's like 0 top left, I mean maximum left, then 255 maximum right, and then the middle one has something like 127 or 128. This is the problem, because on a digital joystick, when nothing is pushed as it is now, the application or game or whatever knows that just no buttons are pressed, so the character should just stay still. Okay. On an analog joystick though, when nothing is pressed, there's still some resistance that goes on inside the actual joystick. So the middle part is not actually sending off signals that nothing is pushed. It is just sending the middle resistance of the variable resistor. So in order to do this, I have some circuitry underneath, and I'll actually get to showing you that. Let me just see if I can rotate this whole thing. Okay. So this whole thing may actually look a bit messy, but it's actually very, very simple. And if you're using digital joysticks that plug in a USB port, this will be even simpler than it was for me. So what's going on here? Basically, the buttons are just extensions of the normal button on the joystick. So when you push a button, you have like two wires and you connect them. Here, I just take these leads and connect them to the original leads of the actual joystick, which means when I push the button, it acts as though I'm pushing the actual button on the actual joystick. And most of the time, when you push a button on joystick, it will actually short the actual button or wire to ground, which means you can maybe kind of see here that this wire goes between two buttons. And this is because it's ground and it's shared with all of the buttons. It's just the difference is the other wire that you're actually pushing. So this is the easy part. Now on the digital joystick, the D-pad or the direction pad will act in the same way. So if you push left, you will just connect those two buttons and it will go left and everything will be fine. On an analog joystick though, you have to do some tricks in order to force these three states. And when I say three states, I actually mean pushing the joystick left, leaving it in the middle, and pushing it right, because these are the three kind of states you have on a D-pad. Of course, this goes for top and bottom as well. So this circuitry over here, and I'll actually detail this on my blog because I don't want to really explain it because it's difficult to see this way, does exactly this thing. It actually sends off the middle resistance when nothing is pushed. And then if I move my joystick to the left past a certain threshold, it will actually send the minimum resistance, and if I move it to the right, it will send the maximum resistance. So all the resistances in between those, all the states I should say, on the variable resistor in between, are not important at all. And the reason you see, maybe you can actually see that there are like 6 transistors over there. The reason there are 6 of them is because one of them acts for the left and right stick of the first player. Another one is for the top and bottom movement. And then these two are for left, right and top, bottom of the other joystick, the player 2 joystick. And the ones underneath are actually button clicks that I did in the same way. And what I mean by this is basically if you imagine a modern day let's say an Xbox controller or something like that, you have two trigger buttons on the left and the right side of the joysticks. Well, the trigger buttons function in more or less the same manner. The harder you press them, the more or the less resistance you actually send out through the joystick, depending on the implementation. So what I did here is that I took this opportunity to get 2 more buttons out of this. So I'm treating the released button as one button press and the completely clicked button as another button press. So I'm kind of simulating button clicks by using triggers. And this is something that you can actually do quite easily with this type of circuitry. Over here you can actually see the PCB of one of the joysticks, and I left that PCB here because this joystick has actually some integrated circuit over here. It probably has to do with the rapid fire functionality, I'm not exactly sure, but I figured I can just leave it in, and whatever it does, just leave it do its thing. And I just connected leads out of it that go to the button and to the actual joystick. Okay, let me just go back here. Again, I'll have details on how to actually do this type of thing if you're gonna use analog joysticks on my blog. But please, if possible, just get digital joysticks. They're really cheap, you can find them everywhere, and they connect to a USB port, so you don't have to bother with these crazy old ports, which actually you won't be able to find on any motherboard that's bought like recently, even not so recent. Okay, I don't know what else to actually show you here. Okay, so here's what this MIDI port actually looked like a while back, and these whole things are now integrated into motherboards. You don't buy an external sound card. I mean, not you know, you usually buy an external sound card if you want something premium, not, you know. Okay, so for future improvements, what my plans are to actually take this panel and implement this whole thing in a, like an arcade looking box. I don't really, I'm more of a computer hardware and software kind of guy, so I don't really work with wood too much, so I'm probably gonna leave that to someone else. But my intentions are to kind of implement this along with the monitor into some type of box, and maybe tilt the monitor a little bit, and then put plexiglass on top of it so that it looks like a real arcade. Okay, let me just get my camera to focus. Okay, that's it. Then I'm gonna put the motherboard with processor and everything inside that box as well. I'll probably replace this speaker with you know, just more powerful speakers inside, and then put an extension cord so that I can plug in the new speakers, the monitor and the power supply into one extension cord, and have only one cable coming out of the box, because I don't think it's necessary to have all three cables coming out separately. Of course, I'll replace my ghetto style power on switch with something more, there it goes, with something, you know, more pretty to look at and press. I don't know if I mentioned, but I'm running Windows 98, because I mean it's Pentium 2 computer, and then I have MAME32 as my emulator for arcade games. So this is actually, I was actually thinking of implementing some type of like coin registering system in here, so that you actually need to put coins in, just like on a real arcade. But you know, this is just too much of a time requirement, which I don't have, so right now the coins are just added with a push of a button. So I can actually demonstrate how this whole thing functions right now. I have a game selected over there, and just power it on. Okay, so this is the actual arcade machine just initializing, and then this button here is actually the button that put coins in, and this button here just initializes a one-player game. Okay, so you might recognize this game. It's Cadillacs and Dinosaurs, and I'll just push something. Yeah, okay, so you see I can actually, you know, hit buttons, jump, hit whatever. I'm doing this right here, and then on the actual joystick I can actually move the character around. So you get this you know, exact feeling like you would on a regular, like you would. Okay, let me just switch it off because I'll start playing the game now. You get the same authentic feeling that you do on a regular arcade, with the difference being that, you know, you can have like thousands of games over here, and not worry about like running out of quarters or anything like that. That's pretty much it. I'll try to have as much information available on my blog as possible, so that if someone wants to replicate this, you can actually do the analog to digital type of conversion and things like that. I'm really interested if anyone, you know, sets off to building something like this, how you end up doing it. So feel free to leave a video response or anything like that, and feel free to like leave any questions or comments. I'll try to answer as much as possible, even though I'm kind of busy these days, but yeah. Okay, so that was more or less it. Thank you very much for watching, and I'll see you next time. Bye bye.